Welcome back. In 2026, the landscape of artificial intelligence has split into two very distinct, very powerful camps. On one side, we have the behemoths, the state of the art, or SOTA, cloud models. We're talking about GPT-5.5, Claude Opus 4.8, Gemini 3.1 Pro. On the other side, we have the challenger, the local LLM revolution powered by open weight models like Llama 4 and Gemma 4 running directly on consumer hardware. Just a couple of years ago, the idea of running a genuinely useful agentic AI on your personal laptop was a pipe dream. You had to pay the cloud tax. But today, the gap is closing rapidly. So, the ultimate question for developers, businesses, and power users isn't just which model is smarter, it's which model architecture makes sense for my specific use case. Today we are breaking down the exact trade-offs between cloud APIs and local models regarding privacy, performance, and cost. Let's start with the undisputed heavyweight champions, the state-of-the-art cloud models. These models represent the absolute pinnacle of human computing achievements right now. Because they are hosted on massive centralized server clusters costing hundreds of millions of dollars to maintain, they can perform tasks that local models simply cannot. They feature unmatched reasoning capabilities, deep logic chains, and massive context windows that easily exceed 1,000,000 tokens. If you need an AI to read an entire codebase, cross-reference it with 3 technical manuals, and rewrite the architecture, you need a frontier cloud model, period. They also have native web integration, meaning they can pull real-time data seamlessly. But this raw power comes with significant strings attached. Every time you hit enter, you are sending your data to a remote server, you are paying a toll per token, and you are entirely dependent on their network uptime. This brings us to the local LLM revolution. If you've been paying attention to open source in 2026, you know that models like Llama 4 Scout, Google's Gemma 4, and Qwen 3.5 have fundamentally changed the game. By utilizing inferencing engines like Llama or LM Studio, you can now run highly capable AI models directly on your hardware. If you have an Apple Silicon Mac or a PC with a modern NVIDIA RTX graphics card, you have an AI powerhouse sitting on your desk. The appeal here isn't that they beat GPT 5.5 in a reasoning test. They don't. The appeal is sovereignty. They aren't renting intelligence, you own it. It runs on your silicon. The response time is instantaneous, there are no rate limits, and most importantly, your data never leaves the physical room. So there's still something that we need to address, and that's the elephant in the room: output quality. There is still a measurable gap between what a trillion parameter cloud model can do versus a 70 billion parameter local model squeezed into 64 gigabytes of RAM. Looking at the current benchmarks for complex reasoning and agentic software engineering, cloud models like Claude 4.8 and GPT 5.5 sit comfortably in the mid-90th percentiles. Local models, while vastly improved, generally score around 10 to 15 percentage points lower. If you are asking an AI to architect a complex microservice backend from scratch, the cloud model will get it right on the first try much more often. But, and this is a big but, for everyday tasks like code autocomplete, formatting data, summarizing documents, or drafting emails, a local model is more than capable. It has crossed the threshold from toy to indispensable tool. And that brings us to the single biggest reason enterprises and developers are pulling workloads from the cloud: the privacy imperative. When you use a local model, there is zero telemetry. If you are feeding patient records, proprietary corporate source code, or attorney-client privilege documents into an AI, sending that to a third-party server creates a massive compliant risk regardless of their privacy policy. Local models offer absolute data security because they can operate completely air-gapped. You can unplug your router, and your AI keeps working. Furthermore, you avoid vendor lock-in. You don't have to worry about a cloud provider updating their model and suddenly breaking your carefully crafted prompts, or worse, shutting down your access. So now, let's talk about money. The financial model for AI is essentially a battle between operating expenses, OpEx, and capital expenditures, CapEx. Cloud APIs are OpEx. You pay per million tokens. For casual users, this is dirt cheap, maybe a few dollars a month. But if you're building an automated pipeline that processes 10 million tokens a day, that linear cost scaling becomes a massive financial drain, easily costing tens of thousands of dollars a year. Local hardware is CapEx. Yes, dropping $3,000 to $5,000 on a Mac Studio or an RTX 5090 rig hurts up front. But once that hardware is on your desk, your marginal cost per token drops to exactly zero. If you have stable, high volume, repetitive AI workload, local hardware pays for itself in a matter of months. So now, there is the issue of speed. When you create a cloud model, the server generates tokens incredibly fast, sometimes up to 200 tokens a second. But you are at the mercy of network latency. The round trip of the server and back introduces a delay which is fatal for real-time applications, which, let me just correct the script. A local model is going to be slower. So here it is. If you run a local model on a standard CPU, it's going to be slow, around 10 to 25 tokens a second, which is about 100 times slower than a cloud model. However, if you are utilizing local GPU acceleration, you can easily match cloud generation speeds. This isn't true, by the way, unless you're running multiple instances of a GPU. And because the model is local, your time to first token is practically zero. For embedded UI applications or voice assistants, that zero latency response is what makes the AI feel like a native part of your computer. So let me just actually edit this part. This is incorrect unless you're running really expensive GPU setups or a Mac Mini Studio. So on my current Mac setup, yeah, I can probably get like 40 tokens a second, which is great if I'm just trying to chat. But again, for coding and stuff, it'll take longer, maybe 10 to 15 minutes to respond. So just keep that in mind. The script is a little bit inaccurate. So which one should you use then? Honestly, it really just depends. It depends on your use case. If you're dealing with really sensitive data, PII, or proprietary code that you don't want to get leaked, local is clearly the winner. Now, if you have really complex architecture or you need really high reasoning or you're tackling a problem that you barely understand, cloud is the winner. If you're doing high volume batch processing, like categorizing 100,000 product reviews, local will save you a fortune. And if you need real-time web search or current events, cloud is your go-to. There is a caveat though. Some providers like Llama or LM Studio do allow you to do web search, so just keep that in mind. Depending on what kind of harness you're using, you might be able to use the web search. And genuinely, it's just about matching the tool to the task. You're not going to use a hammer when you need to solve something. So ultimately, the debate between state-of-the-art and local LLMs is not a zero-sum game. You don't have to choose just one. In fact, the most sophisticated developers and organizations today are building hybrid stacks, which is what I use as well. They use an fast local model like Quen or Llama or the smaller Gemma running in the background for code autocomplete and routine text formatting, keeping their data safe and their costs at zero. But when they hit a wall and need a heavy-duty logic, they seamlessly route that specific query out to Claude or GPT. The future of AI isn't entirely in the cloud, nor is it entirely on your desk. It's the intelligent routing between the two. Understanding the trade-offs, build a hybrid workflow, and take control of your AI infrastructure. Thank you guys for watching. I'll see you in the next one, and I hope you enjoy this format better. I actually scripted this time, so it's not as jumbled as other times.